All right, problem number 14, last problem of our review packet. It says the half-life of carbon-14 is 5,715 years. It says if 41% of the original amount of carbon remains in a fossil, then how much time has passed from the time that decay started to occur? Well, this is one of those good, fun, thought-provoking challenge problems that you guys enjoy doing. So let's get started. And you know this is a decay problem, so we use our exponential growth or decay model. Y equals c times e to the k times t power, and let's get started. Let's fill in our values here. Y equals c equals k equals t equals. Well, y, the ending amount we don't know, the starting amount we don't know, but we know that 41% of the original amount remains, so let's call the ending amount 41 and original amount 100. It's 41%. There's other ways you could set these values up to make 41%, but this is our idea. K, well, thanks to Brian Vleck and Vleck's theorem, we know that K is going to be the natural log of 1/2 divided by 5,715 years. And T, that's the unknown. So let's substitute into our equation now. So we'll say 41 is equal to 100. We ended with 41, we started with 100, so we ended with 41% of the original amount, times e to the natural log of 1/2 power for 5,715 years times t. Now we just need to solve for t. Oh, let's divide each side by 100, so we'll say 41 divided by 100 is 0.41, times e to the natural log of 1/2. That's getting a little cramped. Let's give ourselves a little bit of room to write neatly. 0.41 equals e to the natural log of 1/2. I don't know what that has. Divided by 5,715 times t. Now our variable t is in the exponent of a problem, so the way we get a variable out of the exponent is by taking a log. Well, base e, log base e is natural log, so the natural log of 0.41 is going to be equal to the natural log of 1/2 divided by 5,715 times t power. To get t by itself, we need to get rid of this fraction. Divided by a fraction is the same as multiplying by its reciprocal, so we're going to say that 5,715 divided by the natural log of 1/2 times the natural log of 0.41 equals t. Now it's calculator time. Of course, 89 users could have solved this equation from the beginning with their calculator, but we're not taking the easy way out. We're practicing our skills. Now let's get that calculator. And we get t is about 7,351 years, 7,351.228 years. So we'll say about 7,351.228 years have passed since decay started to occur. All right. It's interesting, and that was all algebra. We didn't do any calculus there. We didn't find a limit. We didn't differentiate. We didn't integrate. All we did was algebra. There's a part B to this problem. Let's go see what they were asking. If you need to look at this solution any longer, the solution guide is also attached just with the text, without the video, without the audio. Feel free to check it out or just pause the video. Now it says, if 1,000 years had passed from the time that decay started to occur, then what percent of the carbon remains in the fossil? You know what, let me get rid of the scratch work from part A so we can see that problem when we set up our thoughts. If you need to see this work anymore, pause or rewind the video, please. All right, here goes. Another thought-provoking challenge problem for your edification and enjoyment. Let's see what we can do here. Set up our growth and decay model. Let's see what values we can replace. Okay, Y is the ending amount. C is the starting amount. I don't know much about that. Let's see if we can figure something out. K, well, we know it's carbon. So according to Vleck's theorem, K is going to be natural log of 1/2 divided by 5,715. And time is 1,000 years. And I want to know what percentage, and we have a little bit of a problem because there's two unknowns right now. But remember, percent is part over whole. So if we started with 100 grams, for example, and we ended with something, the ending amount would tell us the percentage. Because you start with 100, you end with, say, 58. That means 58 out of 100 is 58%. So let's go to work. We'll say y equals 100 times e to the natural log of 1/2 divided by 5,715 times t times 1,000. So we'll just go to our calculator. And you see that y is approximately 88.578. It doesn't matter if you start with 1 gram, 10 grams, 100 grams, 37 grams. It's 1,000 years, about 88, between 88 and 89% of the carbon will be remaining. So to answer the question, let's see here. After 1,000 years, about 88.578% of the carbon remains, of the carbon-14. Remains. And there you go. That's the last problem on our review packet. Thank you for working hard to understand these problems. Thanks for taking the time to watch the videos. Hopefully they were helpful. Good luck with the rest of your studying and good luck on your test.